I'm Rashna Kumar, a final year PhD candidate at Northwestern University. Today, I'm presenting our work, Who Holds the Steering Wheel? Opacity and Consolidation in CDN Replica Selection. This is a joint work with my advisor Fabian and collaborator Marcel. In this talk, I'll show how we can infer any CDN's replica selection mechanism without privileged access using latency fingerprints and what we learn when we apply our methodology at scale. Web content is increasingly served through CDN replicas hosted around the world. Replica selection is one of the quiet control planes of the internet. It determines where traffic goes, what latency users see, and how failures propagate. Yet, the decision process is almost entirely opaque to outsiders. We ask a simple question: who is actually steering user traffic, and how concentrated is that control? Our goal is to make steering observable from the outside without privileged access and without cooperation from CDNs. CDNs, which host most of the web, steer requests using internal policies we don't see. But the consequences are very visible, such as traffic localization, failure behavior, and jurisdictional exposure. There's also a structural wrinkle. Resolver geography can distort where users are mapped, meaning the entity influencing replacement may not be the user at all. Prior work has mostly evaluated performance. We focus on something more fundamental: deployment reality, how steering is actually implemented at internet scale. Our key idea is straightforward. DNS steering mechanisms leave distinct latency fingerprints. So, we resolve the same content through resolvers placed at multiple geographic scopes. Measure the RTT to the assigned replicas and compare the resulting distributions. Those differences let us infer the strategy: DNS-based, IP anycast, or regional anycast, without privileged access and at scale. For DNS-based steering, we expect distributions to separate strongly as resolver scope changes, because the selected replica changes with resolver location. For IP anycast, distributions should look very similar, because the same anycast IP leads to the nearest instance regardless of the resolver used. Regional anycast should match IP anycast within a region and DNS-based steering across regions. To test this idea in the real world, we run a simple controlled experiment. We use RIPE Atlas probes as fixed end-user clients spread across many networks and countries. For each probe, we resolve the same domain through 5 DNS resolvers at increasing geographic scopes, from local to far. For each resolution, we record the replica the CDN returns, and we measure the RTT from the probe to the replica. Because the client stays fixed and only the resolver changes, any systematic shift in RTT across scopes reflects this steering mechanism. Then we compare the RTT distributions across scopes to infer how the CDN is steering. Once we have these RTT distributions across resolver scopes, we need a compact way to summarize the pattern and classify it. That is what we call CRV. CRV is a 4-element vector, measuring how different the RTT distribution is between the local resolver and a further resolver scope, where CRVI is computed as the KS distance between the latency CDF from the local resolver and that from the I+1th resolver scope. CRV1 and CRV3 capture inter-country, that is local versus same region, and inter-regional variation, that is local versus far region, the strongest signals for distinguishing strategies. The patterns line up with the intuition from before. For DNS-based steering, this distribution changes a lot across scopes, so CRV values are high. For Anycast, they barely change, so CRV values are low. For regional Anycast, they stay low within region, but jump when you cross regions. So CRV gives us a simple signal that lets us classify steering at scale. Before measuring the ecosystem, we validated our methodology against CDNs whose strategies are well understood. Akamai shows the expected DNS pattern, Cloudflare collapses towards zero, classic Anycast. Edgio falls in between, aligning with regional Anycast behavior, that is low within region, high across regions. All correctly identified, so the fingerprint holds. With that validation in place, we scale up to measure steering in the wild. We ran our measurements across the top 1,000 sites in each of 19 countries, covering about 66% of internet users. Using the same pipeline, we classify the steering behavior of 17 CDNs. And importantly, our vantage points span 6 regions, so this is not biased to one part of the world. With this scope, we can now ask what steering strategies dominate globally and how that varies by region. Now, to the first global takeaway. DNS-based steering dominates. Across our dataset, 12 of the 17 CDNs use DNS-based redirection, and DNS-based CDNs dominate overall prevalence and delivered bytes. Regionally, DNS-based is the most common strategy almost everywhere, except Europe, where Anycast is more common. DNS-based steering dominates overall, but some CDNs use more than one mechanism. Google is a clear example. Across Google resources, we see a roughly even split between DNS-based steering and IP Anycast. So steering is not one strategy per CDN, it can vary across services within the same provider. And that raises the question, is this hybrid model the direction CDNs are moving toward? To close, the key takeaways are this. Replica selection is hidden, but it shapes outcomes. We make steering observable with unprivileged latency fingerprints, and at scale, we see DNS-based steering still dominates, with regional variation and mixed strategies in large CDNs. As DNS resolvers consolidate, influence over steering concentrates, raising questions of resilience, sovereignty, and control. This work makes those questions measurable at internet scale. Thank you.